Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square minus 4d plus 3 into y equals to 2x e power 3x plus 3 into e power x cos 2x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so 2 will be our order. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y minus 4dy plus 3y equals to RHS part. We know that d is a differential operator. Then d square will be right. Now let's write the equation as d square y by dx square minus 4 into dy by dx plus 3y equals to 2x e power 3x plus 3 e power x cos 2x. Here d square y by dx square is the highest derivative, so our order will be 2, and highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square minus 4d plus 3 into y equals to 2x e power 3x plus 3 into e power x cos 2x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 4d plus 3 and q equals to 2x e power 3x plus 3 into e power x cos 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is our homogeneous equation to our given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Okay. So let's begin with auxiliary equation to find yc, and later we'll find yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 4d plus 3. Let's replace differential operator by m, so that we'll get f of m equals to m square minus 4m plus 3. Now our auxiliary equation becomes m square minus 4m plus 3 equals to 0, right? Now let's split minus 4m as minus m minus 3m plus 3 equals to 0. Now take m common from the first two terms. We'll get m times m minus 1, and take minus 3 common from the next two terms. We'll get minus 3 times m minus 1 equals to 0. See, minus 3 into m is minus 3m, minus into minus plus, 3 into 1, 3, right? You notice we are having m minus 1 in both the terms. So let's take m minus 1 common. We'll get m minus 1 into m minus 3 equals to 0. Now equate each factor to 0. From m minus 1 equals to 0, we'll get m equals to 1. And from m minus 3 equals to 0, we'll get m equals to m equals to 3. So the roots are m equals to 1 and 3, which are real and distinct, or we can call it as real and different roots of our auxiliary equation. Therefore, m equals to 1, 3 are the roots of our auxiliary equation, say f of m equals to 0, which are real and distinct. We know that when two roots say m1 and m2 are real and distinct, then complementary solution looks like, complementary function, looks like one constant into e power 1 root into x plus another constant into e power another root into x. Now coming to complementary function of our problem. Y is equals to one constant into e power 1 root into x plus another constant into e power another root into x. Then yc will be c1 e power x plus c2 e power 3x. So this is a complementary function. Now let's find particular integral. We can find particular integral using 1 by f of d into q. We have f of d in q, where f of d is d square minus 4d plus 3 and q is 2x e power 3x plus 3 e power x cos 2x. We can write this as 1 by f of d into 2x e power 3x plus 1 by f of d into 3 e power x cos 2x. Okay, let's write constant 2 and 3 before 1 by f of d. Okay, towards left beside 1 by f of d. We get 2 into 1 by f of d into x e power 3x plus 3 1 by f of d into e power x cos 2x term. Okay, we'll just have only terms involving x here. Now let's find each term separately. Okay, for our convenience, we'll find each term separately. First one, I'll find 1 by f of d into x e power 3x. This of 1 by f of d into e power ax into v form, right? We'll shift e power x towards left by replacing differential operator with d plus a, and later we'll operator v with 1 by f of d plus a. Okay. Now compare e power 3x with e power ax, and for a equals to 3 we'll find d plus a, which is equals to d plus 3. Now shift e power 3x towards left by replacing d with d plus 3. We'll get d plus 3 whole square minus 4 into d plus 3 plus 3 into v x is equals to e power 3x into 1 by expand d plus 3 whole square. We'll get d square plus 3 square 9 plus 2 3s are 6 into d 6d minus 4d minus into plus minus 4 3s are 12 plus 3 into x is equals to e power 3x into 1 by d square plus 6d minus 4d is plus 2d, right? 9 plus 3 is 12 minus 12 into x. Here plus 12 minus 12 gets cancelled, and you'll get e power x into 1 by d square plus 2d into x. This becomes e power 3x into 1 by, take d common from the denominator, we'll get d times d plus 2 into x is equals to e power 3x into, we can split the fraction as 1 by d into 1 by d plus 2 into x is equals to e power 3x into 1 by d into, now take 2 common from the two terms of denominator. Since this d has no 2, so we'll multiply and divide 2 to this d, so that it will be easy to take 2 common in the next step. This becomes e power 3x into 1 by d into 1 by, now we are taking 2 common from these two terms, we'll get 2 times d by 2 d by 2, or 1 by 2 into d is d by 2 plus 1 into x is equals to e power 3x into 1 by d into, again we will split this fraction as 1 by 2 into 1 by d by 2 plus 1 into x is equals to e power 3x into 1 by d into 1 by 2 into 1 by, we can write d by 2 plus 1 as 1 plus d by 2. So this is of 1 by some 1 plus x form. We can write it as 1 plus x whole inverse, right? Is equals to e power 3x into 1 by 2 is e power 3x by 2 into 1 by d into, now we'll write this as 1 plus d by 2 whole inverse into x. So this is d, okay? We have e power x by 2, sorry, e power 3x by 2 into 1 by d into 1 plus d by 2 whole inverse into x. See here we are having x, right? Or we got this term from e power 3x into 1 by d square plus 2d into x, right? And this is of 1 by some function of d into x for k form, or we know that 1 by f of d into x for k, right? Here for k equals to 1, we'll get derivatives of x for only d, okay? And d square of x, d cube of x, and so on becomes 0. We'll see that. Since we have x to the power 1, so we'll get only one derivative. I mean the value of derivative of x. Only one derivative of x value we'll get here. Let's find derivatives of x. We know that derivative of x with respect to x is 1. Now let's find d square of x. D square of x is derivative of x, which is equals to derivative of, the value of derivative of x is 1, and derivative of constant with respect to x is 0, right? D square of x is 0, likewise d cube of x is 0, and so on. We'll get all higher derivatives of x 0. In general, we can write it as d for k of x is 0 for k equals to 2, 3, and so on, right? Since we are having x to the power 1, so we got only one derivative. Fine. Now keeping this in mind, we'll find the expansion or binomial series expansion of this. We'll use binomial series expansion. 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on, right? Now let's expand 1 plus d by 2 whole inverse by keeping all these derivatives in mind, okay? We can neglect higher derivatives from d square, d cube, and so on, right? This is equals to 1 minus, just compare 1 plus x with 1, or 1 plus d by 2 with 1 plus x, then for x equals to d by 2, we'll get 1 minus d by 2 plus d by 2 whole square minus d by 2 whole cube plus so on, right? This equals to 1 minus d by 2 plus d square by 2 square minus d cube by 2 cube plus so on. We know that derivatives or d square of x, d cube of x, so on becomes 0. So we can neglect d cube, d square, d cube, and from here we can neglect all the higher derivatives because we are going to get those derivatives of x 0. Right? So we'll take only the first two terms. Now coming to the problem. This becomes e power 3x by 2 into 1 by d into 1 plus x whole inverse expansion is 1 minus d by 2 plus d by 2 whole square minus d by 2 whole cube plus so on into x, which is equals to e power 3x by 2 into 1 by d into 1 minus d by 2 plus d square by 2 square minus d cube by 2 cube plus so on into x, since d power k of x equals to 0 for k equals to 2, 3 and so on. So neglect higher derivatives from d square, d cube and so on, right? So we are going to neglect all the terms from here, okay? And we'll have only the first two terms. Then this becomes e power 3x by 2 into 1 by d into 1 minus d by 2 into x. This becomes e power 3x by 2 into 1 by d into 1 minus 1 by 2 into d. I'm just writing d by 2 as 1 by 2 into d. Is equals to e power 3x by 2 into 1 by d into 1 into x is x minus 1 by 2 into derivative of x is equals to e power 3x by 2 into 1 by d into x minus 1 by 2 into derivative of x is 1. So we'll get e power 3x by 2 into 1 by d into x minus 1 by 2. We know that 1 by d is a differential operator. So we can write 1 by d as integral of x minus 1 by 2 into dx, which is equals to e power 3x by 2 into integral x dx minus integral 1 by 2 dx. Now write the constant outside the integral. We'll get e power 3x by 2 into integral x dx minus 1 by 2 into integral dx, which is equals to e power 3x by 2 into integral x dx is x square by 2 minus 1 by 2 into integral dx is x, which is equals to e power 3x by 2 into x square by 2 minus 1 by 2 into x is x by 2. Now take the LCM. We'll get e power 3x by 2 into x square minus x by 2. Now we'll split this fraction as 1 by 2 into x square minus x. This is equals to e power 3x by 2 into 2, 4 into x square minus x. Therefore, 1 by d square minus 4d plus 3 into x e power 3x equals to e power 3x by 4 into x square minus x. Okay. Now let's find the second term. So this is of 1 by f of d into e power ax into some b form, right? Again, we'll shift e power ax towards left by replacing differential operator with d plus a into b. And later, we'll operate b with 1 by f of d plus a. So now compare e power x with e power ax, and for a equals to 1, we'll find d plus a, which is equals to d plus 1. Okay, let's shift e power x towards left by replacing d with d plus 1. We'll get d plus 1 whole square minus 4 into d plus 1 plus 3 into cos 2x, which is equals to e power x into 1 by expand d plus 1 whole square using a plus b whole square formula. We'll get d square plus 1 plus 2d minus 4d minus into plus minus 4 into 1 4 plus 3 into cos 2x, which is equals to e power x into 1 by d square plus 2d minus 4d is minus 2d plus 1 plus 3 is plus 4 minus 4 into cos 2x. Here plus 4 minus 4 gets cancelled, and we'll get e power x into 1 by d square minus 2d into cos 2x. Series of 1 by some function of d into cos bx form, right? Where g of d equals to d square minus 2d and b equals to 2. For b equals to 2, we'll find d square, which is given by minus of b square, which is equals to minus of 2 square equals to minus 4. Okay, we are having e power x into 1 by d square minus 2d into cos 2x. Now let's see what happens if we replace d square by minus 4 in the denominator. The denominator must be non-zero, because if the denominator becomes 0, we'll get 1 by 0 into cos 2x. Since 1 by 0 is undefined, so total term becomes undefined, right? So always keep in mind that the denominator must be non-zero. Now take the denominator part, d square minus 2d, and replace d square by minus 4. We'll get minus 4 minus 2d, which is a non-zero term, right? So we can replace here, since we got the term denominator becomes non-zero by replacing d square by minus 4. So let's dare to replace d square by minus 4 here. We'll get e power x into 1 by minus 4 minus 2d into cos 2x, which is equals to e power x into 1 by, take minus 2 common from the denominator, we'll get minus 2 times 2 plus d into cos 2x, right? This becomes e power x into, we'll split this fraction as 1 by minus 2 into 1 by 2 plus d into cos 2x. Again we can write 1 by minus 2 as minus 1 by 2 into 1 by 2 plus d into cos 2x. Right? Is equals to e power x into minus 1 by 2 is minus e power x by 2 into 1 by 2 plus d. Here in this fraction, or in the denominator of fraction, we have plus, right? Just replace this plus with minus, then you'll have 2 minus d, right? Now multiply and divide 2 minus d to this fraction into cos 2x. We'll get minus e power x by 2 into 1 into 2 minus d is 2 minus d by 2 plus d into 2 minus d into cos 2x, which becomes minus e power x by 2 into 2 minus d by 2 plus d into 2 minus d. This is of a plus b into a minus b form, so we can write it as a square minus b square into cos 2x, which is equals to minus e power x by 2 into 2 minus d by 4 minus d square into cos 2x, right? Again, d square appears in the denominator, so what we have to do, we have to check what happens if we replace d square in the denominator. We'll get 4 minus d square equals to 4 minus, replace d square by minus 4, we'll get 4 plus 4, 8, non-zero, right? By replacing d square by minus 4, the denominator become non-zero. So what we'll do here, we'll just replace d square by minus 4. Then this becomes minus e power x by 2 into 2 minus d into 4 minus of minus 4 into cos 2x, which is equals to minus e power x by 2 into 2 minus d by 4 plus 4 minus into minus plus, right? Into cos 2x, which is equals to minus e power x by 2 into 2 minus d by 4 plus 4, 8 into cos 2x, which is equals to minus e power x by 2 into, we can split 2 minus d by 8 as 1 by 8 into 2 minus d into cos 2x, which is equals to minus e power x by 2 into 1 by 8 into 2 cos 2x minus d cos 2x. We know that d is a differential operator. This becomes minus e power x into 1 is minus e power x by 2 8s are 16 into 2 cos 2x minus, replace d by dx into cos 2x equals to minus e power x by 16 into 2 cos 2x. Now find the derivative of cos 2x with respect to x. We'll get minus 2 sin 2x, which is equals to minus e power x by 16 into 2 cos 2x minus into minus plus 2 sin 2x. Now take 2 common from these two terms. We'll get minus e power x by 16 into 2 times cos 2x plus sin 2x. 2 ones are 2 8s are. This is equals to minus e power x by 8 into cos 2x plus sin 2x. Therefore, 1 by f of d into e power x cos 2x equals to minus e power x by 8 into cos 2x plus sin 2x. Now coming to yp. Yp becomes 2 into result obtained from the first term is e power 3x by 4 into x square minus x plus 3 into result obtained from this is minus e power x by 8 into cos 2x plus sin 2x, right? 2 ones are 2 2s are. We can write it as e power 3x into x square minus x by 2 plus into minus 3 by 8 into e power x into cos 2x plus sin 2x, which is our required yp. Now let's write the general solution because we got yp and yc. The general solution is given by y equals to yc plus yp. Then, for y equals to yc, we have c1 e power x plus c2 e power 3x plus yp e power 3x into x square minus x by 2 minus 3 by 8 into e power x into cos 2x plus sin 2x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.